Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a compilation of everything you need to know for the completing the square topic. So as you can see, that's going to include small parts of each of the following videos. So the first part will be obviously going through how to complete the square in the first place, then how to complete the square for harder quadratics. This is where we have the coefficient of x squared is bigger than 1, so for example 2x squared or 3x squared or whatever it is. Then we've got a quick bit on how to solve quadratics by completing the square. And finally, we have how to find the turning point coordinates of a quadratic graph by completing the square. If you feel that you would like more in-depth examples on any of these 4 topics, I will link below the individual videos that do go into it in more depth. This video here is just a summary. The final thing to note is that this is a higher tier topic only, so if you are foundation, you can just completely ignore this whole video. So let's jump right into it. For completing the square, we normally use this format when we can't factorize. Okay, so you can, if you have a little look at that quadratic, you can see factors of 3, that when you add them together they make 2. Well, it doesn't work based on the symbols, it doesn't work, is that you can't factorize this one. So how do I actually complete the square? Well, there are multiple methods, but the way that I tend to do it is rewrite this quadratic. So it's going to be the same as that quadratic, it's just in a different format. So just start off by writing the bracket as they've got here with the squared. Because we're just looking at normal quadratics in terms of just 1x squared, you can just chuck the x in straight away. Now we're going to work out the a first. The a is half of this middle term. Okay, so first of all, copy the same symbol that they have. So we have a plus, but you need to half it, okay? You need to divide it by 2. So the a is half of this middle term. So I've got 1. Okay, so let me just put here, divide by 2. That's our first bit, okay? We've got in the brackets now. I'm going to go through this, as I tend to do, kind of explain it more than what you'd actually need to write down. So I'm going to write down an explanation. I'm going to go through it, but you don't need to necessarily write anything other than what I've just put here for now. But I'm just going to explain it to you. Let's say if I was to expand this, x plus 1 squared, those are double brackets, aren't they? It's the same as writing this, x plus 1 times x plus 1. And if we were to expand double brackets, you'll see what we get. Obviously we get x squared, which is what we want here, isn't it? So that's fine. We get plus 1x, and then plus another 1x, and finally plus 1 at the end. And if I simplify that, I get x squared. This bit in the middle obviously comes together, and that's where my 2x comes from. Okay, that's why we have to half it, divide it by 2, because when we expand it, we'll get those 2 halves, put it together, and it will become this middle part again. However, what you can see is we still have this extra plus 1, don't we? But do you see here, we've got plus 3, not plus 1. So, the second part is then figuring out what would be b on the outside. So currently we're at, okay, we've got the x squared, we've got the 2x, however the plus 1 is an issue. So say you're currently at this plus 1 here, how do I get back to 3? Well, I need to add 2, don't I? To make it the same thing. So on the outside I've got x plus 1 squared plus 2 on the outside, that's your b. Because if I were to expand this, I know that I get x squared plus 2x plus 1, and then on the outside add another 2, that brings me back to my original. So I've just rewritten this in a different format, okay? So write x squared plus 4x plus 11 in the form x plus a squared plus b, obviously where a and b are integers. So my first step is draw the brackets, squared with the x because it's just x squared. Copy the same symbol as the middle term, but you're going to half it, okay? So plus 2. From the previous example, we know that if we expand this, we're going to get x squared and we're going to get 4x, aren't we? Let me just quickly write it over here. Just for the second one, so you get an idea. So we're going to get x squared, that's what we want. And obviously we get plus 2x plus another 2x. That's where the 4x comes from, isn't it? But we also get this plus 4 at the end, which obviously you can see we don't want plus 4, we want plus 11. So either you think of it as that, you go, okay, the square of this 2 is 4. So we know that we're currently at x squared plus 4x plus 4, but we want to be x squared plus 4x plus 11. So you just have to say, how do I go from 4 back to 11? What's missing? Do I need to add or subtract something? Well, I actually need to add 7, don't I? So you can do it like that. You can kind of think of it in your head as, okay, I'm not saying expand it, spend your time expanding it, but in your head think, I know that the first 3 parts of my expansion are what I need, and then the last part of my expansion, which is obviously the 2 times 2, or this squared, is not going to be the same number that I have at the top. So you think, okay, how do I go from 2 squared, which is 4, back to 11? The other way to do it, rather than just thinking like that, is obviously the first bit's still the same. I need to put x plus half of whatever the middle term is squared. You then square this bit, okay, square this number, which is basically what we just said, isn't it? Square that, which is 4, but subtract it. Always subtract whatever the square is. And leave your plus 11 on the outside. And then, obviously it's then another line, isn't it? X plus 2 squared minus 4 plus 11 just naturally gives you plus 7. So you've got the 2 options, okay? Either you figure it out in your head and go, oh, okay, 2 squared is 4, I need 11, I need to add 7, you just do that. You can make that jump, that's fine. Or you go, okay, I'm going to square this number, whatever that ends up being, square it, subtract it on the outside, and then just keep the same that they've already given you at the top, and then simplify. Okay, so hopefully that's not too confusing. There are 2 options. I want to make that really clear. It's either one. Okay, pause the video, try something out yourself. It's the same again. As you can see, we have an odd number here, but give it your best shot and use fractions if that's helpful. So I'm going to put in my brackets x, copy the symbol, which is plus in this case, and I have to half the middle term, so 15 over 2 is a fraction. Then I need to subtract 15 over 2 squared, isn't it? So 15 squared is 225, and 2 squared is obviously 4. We still have minus 8. So as you can see, I now need to make my 8 into a fraction with a common denominator so that I can actually subtract them. So as we said, any whole number can be written as itself over 1. However, our common denominator needs to be 4, doesn't it? So I need to times the top and the bottom by 4. So 8 times 4 is 32. And as you can see, if I were to simplify that, 32 divided by 4 is just 8, isn't it? So it's the same thing, it's equivalent. So I've got minus 225 over 4, subtract 32 over 4. And now we just need to subtract the numerators. So copy the same brackets, that's all done already. Minus 225, take away another 32 is minus 257, isn't it? Over 4. And it won't simplify again because, as you can see, 257 is an odd number. So I know I can't simplify it at all or divide it by 4, can I? So that's your final answer. Sometimes you just end up with fractions and that's absolutely fine. Now we're applying it to a harder quadratic. As you can see here, we now have 2x squared, not just 1x squared. So write 2x squared plus 8x plus 5 in the form a brackets x plus b squared plus c, where a, b and c are integers. So if you've seen the first video, you can tell that we have a very similar format here. Obviously, this is still completing the square format. However, we now have a number on the outside of the brackets first, before we then have the same format afterwards. So you can see this bit looks familiar. However, now we have this extra a on the outside. So there are 3 numbers we need to figure out. So it's the same method. The only thing that's different is we're going to add in an extra step at the start. So before we begin, you can see that in the brackets, we still only have x, okay? So we want to separate out the number that's in front of the x squared first. So what I'm going to do is factorize my quadratic. Now again, there are 2 ways to do this, but I'm just going to show you the way that I prefer. I'm actually going to only factorize the first 2 terms. So what I mean by that is I'm going to pull out the 2 because I only want x squared. And I'm also going to pull it out of the 8x. So 8x divided by 2 is just 4x. Close the brackets, and I'm going to leave the 5 on the outside. Okay, so that doesn't need to be factorized. Okay, the 2 is going to be our a, basically. Now from here we can start our completing the square method. So just keep the 2 there for now, and I'm going to use square brackets just for now. And you remember that we said, right, in the brackets we've got x, you copy the symbol, which is plus, and you half, or you divide this term here by 2. Okay, so the number that's in front of the x, you divide it by 2. So that becomes 2. So we've effectively divided it by 2 twice, haven't we? Only because this one on the outside of the x squared was a 2. Sometimes it might be a 3 or a 4 or whatever, but then we half it. So always make sure you write out this step first, because I think it can be quite easy to forget that the 8 needs to be divided by 2 because of this 2 on the outside, and then also halved because of the method. So we've got our x plus 2 squared, and do you remember that when we did our first video we said, right, then you have to subtract this term squared. So I'm going to subtract 2 squared, which is 4. I'm going to close my square brackets. I still have plus 5 on the outside. So you can see this does get a little bit complicated. We've got a few different brackets. Then what I'm going to do is, because can you see that my actual format doesn't have these square brackets? So I'm going to expand out 2 again, however, obviously leaving my squared brackets the same. So what I mean by that is we're going to have 2 bracket x plus 2 squared. So it's effectively like I've done this. And then you also have to then do 2 times this minus 4, which becomes minus 8. And we still have the plus 5 there. And the last bit is just doing minus 8 plus 5, isn't it? So you've got 2 x plus 2 squared minus 8 plus 5 is minus 3. There we've got a, b, and c. You can see a is obviously 2, b is also 2, and c is minus 3. Okay, pause the video, try this one out yourself. As you can see though, it's a little bit trickier because we've not only got x squared, we've got a negative x squared. But let's go through it together. So in this case, as I said, we're going to factorize out the coefficient of x squared. Now that's 4, yes, but I'm also going to factorize out the negative. Okay, so I'm factorizing out negative 4. Not only because having positive x squared is just easier, but also do you see how in the brackets over here we've got x? It's not negative x, is it? So I'm going to factorize out the negative 4. So remember, not only does that mean I'm dividing everything by 4, but I'm also then going to change the symbol. So for example, we've got positive 16x. Obviously divided by 4 would give me 4x. However, positive 16x divided by negative 4 makes it a negative, doesn't it? So be really careful with that. Otherwise, it's the same. We still have our minus 6 on the outside because I haven't factorized that. And now I can go ahead and complete the square. So open my square brackets. X, copy the symbol, minus, and then 4 divided by 2 is 2. So luckily another whole number. Now 2 or minus 2 squared is 4 either way, isn't it? So subtract the 4, close my square brackets. I still have minus 6 on the outside. Now I'm going to get rid of my square brackets. So I've got minus 4, x minus 2 in my normal brackets squared. Now, minus 4 times minus 4 is then plus 16, isn't it? Okay, and then we still have our minus 6. Now we just tidy up the last bit. So minus 4 in the brackets x minus 2 squared. 16 minus 6 is plus 10. There we go. So even if there's a negative there, it's still very straightforward. Just be really careful that you might have to flip some of the symbols, okay? So by completing the square, solve x squared plus 10x minus 1 equals 0, giving your answer in surd form. So we're just going to whiz through and go, right, okay, so first of all, I have to complete the square. So if you remember from our first video, we have one bracket squared, and we put, if it's just x squared, we're going to put x, copy the same symbol that they've given you, which is next to the middle term, and then we half the coefficient of the middle term, don't we? The coefficient is the number in front of, in this case, x. So we're going to half that, which is 5. And then if you remember, we have to subtract on the outside this number squared. So I'm going to subtract 5 squared, which is 25. And then I've still got this minus 1 at the end as well. Now, when we were completing the square just on its own, that was it, wasn't it? When you're solving, you can't solve something that's not an equation, can you? It has to be an equation, so I have to put the equals 0 there as well. So to finish completing the square, obviously I'm just going to do minus 25, take away another 1, which is minus 26, equals 0. That's my completing the square. Obviously I've just chucked the equals 0 on the end because it is now an equation. Now the solving bit is actually the easier part because really it's just rearranging. It's not really, we're not learning anything new here. We're just going to rearrange the equation, but I'm just going to show you how to do that. Because a lot of people, I think with quadratics especially, think, oh yeah, I just need to expand the brackets and so on. In this case, we're not going to, because that's not going to help us. If I were to expand these brackets, I would get back to this. And then what? Well, I know I can't factorize it, so it's not helpful, is it? So in this case, you should end up with something that's negative on this side, on the outside of the brackets. Whatever this number is, move it to the other side of the equation. So in this case, we should be able to add it if we're going to be solving. So add 26, and obviously it's an equation, right? So you have to do it to both sides. So if I add it to the left side, well, that just cancels it out, doesn't it? So I just get left with the bracket squared equals, and then if I add it to the right side, 0 plus 26, obviously just 26. Then what we're going to do is we're going to just square root both sides. The opposite of this square here, we want to open up those brackets, don't we, is square root. Square root both sides. Now I'm going to bring it up over here onto the right hand side, okay? So if I square root the left, it just opens up that bracket, doesn't it? It gives me x plus 5 equals, and then on the other side I get root 26 because 26 is not a square number. That's where we get our surd from, isn't it? Now, when we're solving quadratics again in general, normally, well actually always we get two answers. You might sometimes get two answers that are the same thing, so you feel like, oh, it's only one answer. But it's technically two answers, they're just the same number. Otherwise, most of the time you get two different answers, don't you? Because of the x squared. So that's why it says, giving your answers in surd form, there are two. Now, this is where you go, well, I don't know where the two are coming from, because currently it looks like there's only one answer here. Well, when we square root something, what we have to remember is if you square root a number, we don't know if the original was positive or negative. So let me give you an example separately. 9, I'm going to use an actual square number for this. If I were to square root 9, square root of 9, well, you would say is 3. Yeah, okay, 3 squared makes 9. However, technically, we don't know if it was also originally minus 3. Because you know how when you square a negative, it becomes a positive, doesn't it? Two negatives multiplied together make a positive. So the square root of 9 is not just 3, it's also minus 3. And because we don't have any context of actually which one they're saying is maybe right or wrong, we don't know which one to choose. So you have to basically just go with both. So when you square root both sides, you have to put a plus minus symbol. Because I don't know if originally it was negative root 26 or positive root 26. I don't know that. I don't have any context that lets me know that. So that's where your two answers come from. And obviously you can see what the last thing to do is. If there's a number here, you either add it or subtract it depending. In this case, obviously it's plus 5, so I need to subtract it, don't I, to move it across. And then I've isolated the x. So x equals minus 5 plus or minus root 26. Now, if you can simplify the surd, I would do that. It might be in a calculator exam, so you could just, put root 26 in your calculator. But this one doesn't simplify. And just leave it like that. Okay, so technically one of our answers is, I would leave it like this as my answer, but I'll just show you what I mean by two answers. One of them is minus 5 plus root 26. If I'm going to work that out as an actual decimal, 0.099019, I mean, it goes on forever, right? Hence why we can't obviously factorize it. And the other option is if it were minus 5 minus root 26, that's obviously going to give me a different number, isn't it? So I'm going to do that. So minus 5 minus root 26 is minus 10.099019. A lot of the time they have the same actual decimals, because obviously quadratics are symmetrical, aren't they? Not always, but a lot of the time they do. These are your two solutions technically, but obviously they've asked for it in surd format, so my answer, I'm just going to leave it like this. But that's literally it, so it's not really anything new. If you already know how to complete the square, it's then just going, oh, I just need to remember this is how I rearrange it, but the method isn't really anything new, is it? So they've said here, by completing the square, find the coordinates of the turning point for the graph y equals x squared plus 2x plus 5. Again, they've not mentioned anything to do with drawing a graph. Obviously, if they've shown you a graph and they say, what are the turning point coordinates, you just look at it, right? But they're not really going to do that. I think they would more likely do that in foundation. So we're not going to draw any graphs. What we're going to do is say, right, first of all, complete the square. Okay, that's fine, isn't it? So in this case, keep the y there, though. Just ignore that for now, but just, leave it there, but don't do anything with it. So remember, completing the square, we have x plus half of this middle coefficient, which is 1 in this case, squared. We have to minus that one squared, so 1 squared is 1, isn't it? And plus 5 is still there. Then I'm just going to simplify that last bit. So I've got y equals x plus 1 squared, minus 1 plus 5 is 4, isn't it? Okay, we've completed the square. Even if you get this far, you've probably got, I'd say, about 2 marks already. However, finding the turning point coordinates is only really 1 more mark, which doesn't seem like a lot, but considering it's so easy, I just need to remember, okay, this one is the x coordinate. However, I do need to remember to change the symbol. Okay, so that says 1, I actually need -1. And then this one on the outside is going to be the y coordinate. That one you don't change the symbol, okay? Keep it the same. 4. That's literally it. You complete the square, then you just take those two numbers. Change one of the symbols for the x, but the y is the same. Okay, we're doing the same thing, but you can see here, the part of this one that's a bit trickier, I guess, is just the fact that we've got negative x squared, isn't it? That's the only bit that's trickier. So imagine it as the same as when we did the harder quadratics, where you have a coefficient of x squared that's not 1. In this case, it's -1, isn't it? That's the coefficient, -1. So what we would do is I would actually, to complete the square, I would find it easier because I like to base it in x squared on its own, so positive x squared, but also just 1x squared. I would actually factorize out -1 to make it positive. However, remember that that does change the symbol, so I'm going to partially factorize it. That needs to be -12, so I need to put +12x here. And I'm going to leave the 30 on the outside, just as I do with my harder quadratics. So if I were to expand that, I'd get the same thing again, wouldn't I? Now I can complete the square in the brackets. So I've got x plus half of 12 is 6 squared. I need to minus the 6 squared, which is 36. Okay, and then plus 30 on the outside. Now we want to open up these square brackets. I've got minus, I don't need to write -1 anymore, minus x plus 6 squared. And then technically that becomes plus 36, doesn't it? Because -1 times -36 is a positive answer. Plus 30. Now just simplify the last two numbers. So it's just a bit longer in terms of completing the square. So I've got 36 plus 30 is 66. Okay. Now I just need to derive it in the same way. If you have a number on the outside of the brackets, that type of transformation is actually an enlargement. Technically, a minus x squared graph is still symmetrical, isn't it? It's just upside down instead. So it's actually an N shape instead of a U shape. But the turning point for the original, just y equals minus x squared, is still 0, 0. So that's not going to make any difference. So you're still going to take this as x and this one as y. So our coordinates are going to be obviously the 6, but remember to change the symbol, so -6, and the y is going to be the same, positive 66. So we've got -6 as x and 66 as y. Okay, so this is the last one. Give it a go yourselves and then come back to check your answers. So I'm going to do the same things before. I'm going to just factorize out the 3 from the first two terms. So I've got x squared plus 3x. Leave the 8.75 on the outside. To complete the square, x plus 3 over 2, because 3 is an odd number, so halving it is going to be a fraction, minus that squared, which is 9 over 4, plus 8.75 on the outside. You might want to convert that into a fraction if you like, if you don't have a calculator, or you might want to use these as decimals, it just depends. Let's just see what we feel like here. So I'm going to expand out the square bracket, so we've got 3 x plus 3 over 2 squared still in those brackets, and then 3 times minus 9 over 4. I might put this as a decimal maybe, so that when I add them it's a bit easier. So obviously, as we said, a whole number times by a fraction, you just multiply the numerator, so I've got 27 over 4. So how many 4s go into 27? Well, 6, and then there's 3 quarters left over, aren't there? So actually that is 6.75, isn't it? So you might find that easier, or you might want to change the 8.75 into a top-heavy fraction. It is up to you. Okay, so y equals 3. Seeing as this is in decimals, let's write everything in decimals. 3 over 2 is just 1.5, isn't it? Okay, so 3 multiplied by x plus 1.5 squared minus 6.75 plus 8.75 is going to be positive 2, isn't it? So even though you had decimals there, actually this has come out quite nicely. And from here, again, just ignore the 3 at this point. We've now got our coordinates. So x, remember, change the symbol, minus 1.5 or minus 3 over 2, depending on what you prefer. And the y just comes as it is, doesn't it? So it's coming as a positive. So we've got minus 1.5 and then 2. Or, as I said, if you want it in fractions, minus 3 over 2, 2. That's literally it, okay? So even if there's decimals like this, it might end up that it simplifies quite nicely. So as I said, that's everything on completing the square. Go back and check out the first 2 videos if you feel like you need to double check completing the square as a process. Otherwise, that's everything that we need on this topic. So thanks for watching this video, and leave down below any questions you might have in the comments.